Are you interested in building APIs in Rust for the web? Well, you're in luck because I just built a brand new course for Axum, which will allow you to do just that. Hi, I'm Brooks from Brooks Builds. I run a Twitch channel where I do a lot of live streaming, a lot of Rust programming, and I've also created a few other courses in Rust around game development and front-end web dev. But now we have back-end web dev. In this course, you'll learn everything you need to build a full project, just the back-end only, and we'll be building a project to do application with a database, with local authentication that serves that. Anyways, I hope to see you there if you're interested and that's something that you want to learn. And we'll see you there. Thank you very much. Bye. Thank you for showing interest in the Introduction to Axum course. Before we get into it, I want to talk about some prerequisites that if you have or you do, will just make things a lot easier for us. So, first of all, I don't teach Rust here. So I do.
Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for another video on the Rust programming language. I'm going to be adding this video to my Rust playlist, so if you are not familiar with that playlist, feel free to check it out. You can access it on my channel homepage, or you can go to my channel homepage and then go to the playlists tab and you can find the Rust programming tutorial playlist there, and I should have a link to it in the description and probably in the pinned comment as well, so feel free to check out the full playlist. Now, previously in the Rust playlist, we have covered a lot of different topics, a lot of fundamentals. In fact, if we go over to the channel right now and you look at the channel homepage here on the Home tab, you can open up the Rust programming tutorial series, and we've talked about Rust fundamentals, essentially. We've talked about variables, we've talked about the tool chain, we've talked about how to create modules so you can kind of separate code into different files. We've talked about how to do conditional expressions, what closures are, also known as anonymous functions. We talked about the match expression in Rust and a lot of other Rust fundamentals here. Now, one of the things that's been requested on the channel in the comments, and by the way, thank you very much for those comments, is a video on how to build a web application or web server in the Rust language. Now, when it comes to building a web application in any language, whether it's Rust or Python or TypeScript or anything, there are a lot of different concepts to understand. If you look at just how HTTP works fundamentally, there are lots of different components. There's lots of different ways to pass data in, to get data back. There's things like query string parameters. There's things like path segments in your URL. There are headers or key value pairs of metadata that you can pass in as part of an HTTP request or an HTTP response. Of course, there's different DNS names that you can do to route to different APIs that you're running. And then, of course, there's the body or the payload, which oftentimes is going to be JSON, but sometimes it could be something like a byte payload if you're uploading just a raw binary file or something like that. And so there's all these different components. And then within a lot of stacks or frameworks that you have for web applications, there's a lot of other concepts, things like middleware and route handlers and how do I get JSON payloads from the request and how do I send JSON payloads back in the response and all those types of things, right? So there's a lot of concepts that you really need to understand. There's even things like the content type header to tell the client that's calling the API what kind of data it can send to the web server, as well as what data is being sent back to the client in response. So there's just all these different concepts, right? And there's, of course, authentication and authorization. How do you identify the user? How do you determine what permissions they have to your web application? So this is definitely not going to be a comprehensive tutorial on building web applications in Rust. However, I did want to at least get some basic fundamentals out there just so that you can see how to build out a really basic web API. And then hopefully with your other Rust foundational knowledge, you'll be able to build on top of that and implement some other ideas within there. Now, there are going to be some more advanced topics like application state handling that I've tested out. I don't know if I'll get to it in this video. I probably won't just because I don't quite feel confident enough with it. But there's basically state management where oftentimes your application will have all these different route handlers, right? So, you know, put this resource, post this resource, get this resource, patch this resource, right? All of these different types of handlers. You know, you'll want to understand kind of REST API design fundamentals before you really dive into this video, because a lot of that stuff probably doesn't make sense if you don't understand HTTP protocol and if you don't understand at least some of the basics of REST API design. I'm definitely not an expert with REST API design, so don't necessarily follow everything exactly as I'm doing it here, but you know, use this as just kind of foundational knowledge for how to get a really basic web application, or I should say API, really up and running. Now, there are a couple of really popular frameworks in Rust for web applications. So there is the Axum, which is part of Tokio which is the async runtime that is most commonly used in Rust applications. I think I actually have a couple of videos on the Rust playlist that talk about how to do async in Rust, including with Tokio. And then there's another framework out there called Smol, S-M-O-L, as well. But Axum is part of the Tokio ecosystem, so I figured it kind of made sense to focus on Axum first. I know there's some people that prefer Actix Web as well, but if you look at the star count on GitHub, which is broadly speaking a good measure for popularity, you'll see Axum is just barely behind the Actix Web framework. So you've got 21.8 thousand on Axum and 23,000 on Actix Web. So they're pretty close to each other. You know, they've all got recent updates within the last few days. So there's definitely active development going on with both of these, but just simply due to the fact that Axum is part of the Tokio ecosystem, I just figured it made more sense to start with that one. I don't really have any bias towards one or the other, just aside from that association with Tokio. So, you know, it's always possible that I could do a video on Actix Web in the future if I have the opportunity to. Now, I do apologize. It's been so long since I've uploaded. I genuinely do have some very serious health problems that I've had for well over 12 years now, and it is incredibly limiting on what I can do. So the little bit of functionality that I have, I'm typically focused on my full-time job, which I enjoy very much, and I work in the technology ecosystem, so I get to do a lot of fun things, but it just doesn't necessarily mean I get to produce a lot of content on my personal channel. So thank you so much for everybody that's been supporting with comments and likes and subscriptions. That really makes a huge difference. You know, the fact that I'm over 20,000 subscribers just in the last, I think 2 years ago, approximately, I was at like 6,000 or 6,500 or something like that. So the fact that my channel has grown that significantly, in large part due to this Rust content that I've been putting out, I really do appreciate each and every one of you that is participating in the entire Rust ecosystem. If you're answering questions on forums, if you're asking questions on forums, whether you're, you know, watching content, recommending content, video content to other people, recommending blog posts, there's a ton of great content out there in the Rust ecosystem. In fact, there's a newsletter that I really like called I think it's This Week in Rust or something like that. But it's basically just kind of a brief summary of, you know, what are some new blog posts and what's kind of going on in the Rust ecosystem. So that's a great resource to just kind of keep tabs on what's happening with Rust and any updates like that. But anyway, I don't want to spend too much time on that. I wanted to just focus on building from scratch an Axum application. And I'm going to assume that you've got tools like the Rust toolchain installed. Of course, you can go over to rustup.rs here to grab that. It's cross-platform. You can run it on Windows, on Linux, and Mac OS, of course. So I'm going to be using Windows 11 here on my development workstation, but I also do sometimes use a Linux server to run a containerized development environment. And I've got various setups that I use in different videos. So it's kind of up to you how you would prefer to best run the Rust toolchain, but I'm just going to be running it natively on Windows for now. And of course, our trusty editor, code.visualstudio.com. That is our awesome text editor here, and it's got a lot of cool functionality. I've actually been doing a lot of AI research over the last, year or so. And if you go to the company's page, StratusGrid, that I currently work for, I've actually done a lot of videos on things like Amazon Bedrock, large language models, building agents, and that kind of thing. And I've gotten familiar with this really cool extension for VS Code called RuCode. So I would highly recommend checking out RuCode because it's basically this little agent. It's very similar to how they demonstrate Copilot here, just sitting in a sidebar, but you can ask it questions and just get answers about general programming topics. You can ask it questions specifically about your code base. You can ask it to make changes to your code base for you. And there's just a lot of power in that RuCode extension. So it allows you to build software using a natural language approach, which I think is pretty awesome, honestly. I might do a video on RuCode separately, but you can use RuCode with LLMs like Amazon Bedrock's host of LLMs like Claude and so on. And you can also use Google Gemini, which is really high performance and also very inexpensive. So check out the RuCode extension if you're interested in a helper for coding stuff. Also, there's another extension that I would suggest checking out called Cody from this company called SourceGraph. So SourceGraph has this closed source / open source application called SourceGraph. And it's basically a code indexing solution. So think of it kind of like a personal GitHub where you can search through code and find stuff that you're interested in. But they also have this extension for VS Code called Cody. And it's a little bit less flexible than RuCode, but it is very simple to set up. You basically just create a SourceGraph account, you install the extension, you log into the extension with your SourceGraph account, and then it just auto-completes code for you very transparently. You don't really have to configure anything, it just kind of works. And the accuracy of it is actually pretty surprising. I mean, a lot of the times I'll be like writing a README file in Markdown and it'll just know what I'm thinking and it'll just complete the sentence for me, and it saves tons of typing. And I don't say that lightly because I don't really like little gimmicky tools just to save a few keystrokes, but it legitimately just understands what I'm trying to do. And so I really like this Cody extension, and you might actually see it pop up as I'm writing code as well. All right, so one other thing I wanted to point to before we actually go into some coding stuff is just an example of good REST API design and documentation. So in order for somebody else to consume your REST API that you are building, whether it's an open source project or a company like DigitalOcean or Linode or AWS or Microsoft Azure or whatever, it's very, very important to have good REST API design as well as documentation that clearly explains what the purpose of each API endpoint is. And one of the services out there called DigitalOcean, it's basically a virtual private server provider. You can spin up virtual machines, you can spin up containers, you can spin up databases, all sorts of things. It's a really great cloud platform for, non-enterprise users, kind of small office, home office type of things. And they have really great documentation for their REST API. And I've seen this format of documentation before where it's kind of divided up into service. So there's like a block storage service, there's a container registry service, a database service, and it kind of categorizes everything here. And then you expand that service category and it tells you exactly what operations are available. And it doesn't display the documentation in a really confusing developer-centric format. It's actually very readable. Like it explains in plain English exactly what that REST API endpoint does, and it uses this color coding mechanism so you can think about, am I trying to retrieve information from the API? That would be something like a green get operation, or am I trying to change something in the system or do something dangerous like delete information out of the system? And so delete is red for the delete HTTP verb. For post, it's blue to indicate that you are creating a resource on the server. They've got orange for patch. They've got purplish color for put. So just this entire format of documentation, the color coding, the plain English titles, and then, of course, the very clear and easy to understand, how do I authenticate, right? Okay, you pass in a bearer token as a header. Okay, great. Let's say that I wanted to create some resource. So maybe I want to create a new database cluster. Okay, here's a post operation. What are all of the input parameters that I can specify? Are they path segments? Are they query string parameters? Are they part of the body or payload that I'm passing in, perhaps like a JSON payload, which is very common in a lot of REST APIs? How exactly do I specify these? And are each of these properties or parameters that I'm passing in, are they mandatory? Do I have to pass them in? Or are they optional things that I can pass in if I decide to do some more advanced customization? And so these are all very important things that developers need to know. And so just having the breakdown here of, okay, this is part of the request body. So it's not part of the URL path. It's not part of the query string parameters. It's not talking about headers. It's very clearly talking about the body or payload. And on the right here, it tells you about the example. It shows you the exact data structure so that there's no doubt in your mind about exactly what the payload for the request, as well as the response that you're getting back from the API actually looks like. So DigitalOcean uses this platform. Again, I don't know exactly what platform it is that generates this really nice documentation. I've seen it on some other services as well, though. There's another application out there called Baserow that has kind of dynamic code generation, or I should say API documentation generation based on your database schema. And Baserow is open source / enterprise software as well. So you can actually self-host it like I do internally. And so you can also use the SaaS version as well. But regardless of where you're hosting it, whether you're using the SaaS cloud version or the self-hosted version, you have this built-in API documentation generator that looks substantially similar to this. And it's just very easy to understand because you can see exactly what's required, how do I pass it in, and it basically just makes calling each API very, very straightforward. So check out Baserow as well. It's a pretty cool application. I'm actually a Baserow ambassador as well. I enjoy promoting that application because it's open source. It's optionally paid depending on what advanced features you need as well. So definitely check them out. All right, so let's go ahead, and since I've been talking for 15 minutes now and haven't actually showed any code yet, let's go ahead and actually build a new Axum application. So we are going to go over to docs.rs here, and we're going to be referencing the Axum crate documentation on docs.rs, which is the kind of official crate documentation presentation website. So you can just search for any crates up here, whether it's Tokio, whether it's one of the AWS SDK crates. It's really up to you, but this is where the bulk of the Axum documentation is. Unfortunately, I haven't really found any Axum book similar to like the Rust book or all the similar MD book-based web applications out there that just kind of guide you through how to use it. So the documentation here, even though it is, I suppose, adequate, it can be a little bit confusing for at least myself to kind of grok through. So, just keep that in mind as you're working through this. But in any case, I am going to create a new project. So as we do here, we're going to fire up our shell. We're going to go ahead and go into a Git working directory here. And of course, you should have the Rust toolchain installed. So if I do rust up check, you should see I've got the latest version of the Rust toolchain installed right here. So I'm on 1.87. And so we're just going to do a cargo new, and then I am going to call it vehicle manager -Axum. So this is an example that I'm going to use where we can have like a post operation. So if we're, let's say, building a vehicle management system, maybe you're a auto repair shop, right? And so you need to add customers' vehicles into your database. And so you need the API to basically accept some details about the customer's vehicle, like who's the manufacturer of the vehicle, what's the model of the vehicle, what's the manufacturing year of the vehicle, what's the color of the vehicle, what's the VIN number of the vehicle, and all those types of things. And then also assign a unique identifier to each individual vehicle as it comes into your shop. So just kind of think of it in that context as we're building out this example. And it's not going to be a very complex example, so just kind of bear with me as we work through this example. So then, of course, assuming you have Microsoft Visual Studio Code installed, you can just do code, and then we'll do vehicle manager -Axum, and that will open up our trusty VS Code here. So again, this is a bare bones project. I don't generally like starting with skeletons using example repositories and things like that, because oftentimes example repositories will be out of date, right? They'll have old dependencies, it'll be 8 months out of date potentially. And so generally speaking, I just like to create a new project and add in whatever dependencies I need to make sure that I'm getting the latest version of those dependencies, and I'm not just cloning some skeleton project for a specific purpose, right? Because oftentimes I'm not just building an Axum application, I might be building an Axum application plus I'm also bringing in all these other APIs that I need to work with, whether they're AWS APIs or other third-party providers and things like that. So that's why I typically always do cargo new rather than using some kind of generator to spin up a new project. I don't like all the extra fluff that generators tend to add into projects that I don't necessarily understand unless they very clearly document it, right? So of course, in our cargo.toml here, we don't have any dependencies by default. So one of the things you're going to notice by looking at the example here is that there is the Axum package, obviously, the crate, and then there's also the Tokio main attribute, which if you've watched my other videos, you're probably familiar with that already, because pretty much every Rust application that uses async, generally speaking, is going to be using this attribute on the main function so that the entry point to your application can be set as async. So if you apply that Tokio main attribute to your main function, and then you set your main function as async, that will allow you to have an async application wrapped in Tokio. Now, you don't have to take this approach. There is actually a way to build a Tokio runtime in a non-async or just standard main function. However, it's generally advisable to use this approach because it's very simple. There's no additional configuration, but there is another way that you can set up a Tokio runtime inside the main function directly. I think it's called like the spawn function or something. But what I want to focus on here is basically how we define the Axum application. So there's this struct called a router here, and the router allows us to define routes. So it has this function on it called route or method, and the route is going to take in a couple of parameters here, the path that will invoke that route, and then we also pass in the handler. And the handler in this particular case is a closure, but typically it's just an async function that you define somewhere in your Rust project. It could be in main.rs directly, or you could define a separate module file and put the handlers in there. And so you could categorize, maybe you've got, vehicles and customers and parts and all sorts of different types of resources. You can separate those out into separate Rust module files and simply reference those inside of your main.rs file. But we're not going to get super fancy here. So this is basically saying if I do a get on /, which is just the root of my application, then it's going to execute this async closure here and return the result, which is just a string value. It's just a static string. So then once you've defined your routes, and you can actually call route multiple times on this router, so you can define lots of different routes. Next, you have the listener, and all the listener is, it's part of the Tokio crate, and what this does is it specifies which IP addresses to listen on, and if you want it to listen on all network interfaces with whether it's a local host or the actual private IP or IPv6 addresses that you have on your system, you just set it to 0000, or if it's IPv6, I think you do like square bracket, double colon, closing square bracket instead. And I think that is how you define all IPv6 addresses. And then you specify a colon and the port number that you want to listen on. Doesn't matter what port number you choose, just any port number. Obviously, you'll have to potentially open it up in a firewall, depending on how you're trying to access it, but that's far beyond the scope of this particular video. And then you just await and unwrap the result from the listener. And then finally, once you've defined the listener, then you call Axum serve. So serve is a function directly on the Axum crate here, and you simply pass in the listener configuration that you just created with the IP and port, and then the router, which in this case is a variable called app. I don't know. You could call it router if you want to. You could call it app. It doesn't matter what you call that variable, but you just pass your router configuration into the serve function here. And then, of course, you have to await that as well. Otherwise, your application will just quit and the web server will kind of never run, right? Because you're never awaiting that feature. Okay, so let's go ahead and set that up in our application here. And we are going to be pulling in some dependencies as well. So the first thing we're going to do is add the Tokio package. So we're going to say cargo add Tokio features equals full. Then we're going to add Axum as well. So we'll say cargo add Axum. And there are a few optional features. So if you do cargo add Axum and you look at the feature list here, these are the default features that were enabled. But you'll also notice that there's some optional features down here. I'm not quite sure what these double underscore ones are here, but there is a feature here for HTTP version 2. There's one for additional macros. There's actually a macro called debug handler in Axum that's used to help you get better error messages from your route handlers from the compiler. And then there's also support for HTTP multipart uploads, and then of course for WebSockets. WS, I believe, is just short for WebSockets there. And so that is not enabled by default. So if you wanted to add any of those features, you would just say cargo add Axum -- features equals, let's say HTTP2, and then we could say comma macros, comma WS. And so then if we scroll up again, you'll see that WS now has a plus, and so does macros, and so does HTTP2. So we are all good there. So now that we've got the Axum crate installed, there is going to be another one that we need, which is called Serde. And I actually did a video on Serde on serializing and deserializing JSON data. So let's do cargo add Serde. And then just like with the Axum, I actually did a video on installed. There is going to be another one that we need, which is the Axum crate installed. There is going to be, so now that we've got the, we are all good there. And so does HTTP now has a plus. And if we scroll up again, comma WS. And then we could say comma macros, comma WS. And so then if we scroll up again, you'll see that WS now has a plus, and so does macros, and so does HTTP2. So we are all good there. So now that we've got the Axum crate installed, there is going to be another one that we need, which is called Serde. And I actually did a video on Serde on serializing and deserializing JSON data. So let's do cargo add Serde. And then just like with the Axum crate, when you add the Serde crate to your project here, it's not going to enable certain features by default. So there is a feature here called derive that allows us to use the derive macro to add serialize and deserialize traits to our own custom structs that we're going to build. And so we don't need SERDI JSON in order to do JSON serialization, deserialization, because Axum actually handles that for us using something called extractors. And so what we're going to do is add SERDI features derive here. But we're not going to install the SERDI JSON package. So this is going to allow us to basically just mark some of our data structures as deserializable or serializable, and then we can use those inside of our Axum route handlers to either send data back to the client in a response as JSON, or to receive a JSON payload from a client and interpret that as a data structure on the Rust server side. So that's why we add the derive feature here. And then I think that's pretty much everything that we need for now. There is actually one other crate that I almost forgot. I always add UUID as well. And this is just because when you are generating any kind of unique identifier,
Enter to Bluetooth. Bluetooth connected.
UID as well. And this is just because when you are generating, that I almost forgot, I always add UUID as well. And this is just because when you are generating any kind of unique identifier, like we were talking about, anytime that we add a new vehicle to our auto shop, we want to have some kind of unique identifier. And you could potentially use the vehicle identification number or VIN number, but oftentimes you want to use some alternative to that because you can get in weird situations where you might have duplicate entries or something like that. And so it's really just best oftentimes to use UUIDs, Universal Unique Identifiers, also known as global unique identifiers, depending on who you talk to. But that package just really helps with generating random values so that you have these, unique identifiers for various objects in your applications. Okay, so we are going to open up the source main.rs file. And the first thing we're going to do is actually set up the Tokio async runtime here. So we're going to do Tokio main. And then we're going to, of course, set our async main function here. If we don't have async there and we do apply the Tokio main attribute up here, you'll see it actually complains and says, hey, the async keyword is missing. So, make sure you add that. So it's not even going to compile unless we add async there. So then we are not really going to copy here. We're going to type this out. And what we're going to do is basically create a new router. So we're just going to call the new function on the router type, and then we're going to call the route function one or more times on that router struct so that we can define one or more routes that we want to define. And then this get function here. So this is the verb that we're going to use for the HTTP API endpoint. So there is Axum, and then there's a child module called routing, and then under the routing module there is a function called get, and there are also other functions. If we go to create items, modules, and then go to routing, there are other functions here for the other verbs in HTTP. So if you are doing a post operation, you would use the Axum routing post or put or patch or options or head. Those are all the common, or delete there. Those are all the common HTTP verbs or methods that you'll see when building out APIs. And I think there's even support for custom. I think any might be how you do that. I haven't really dealt with custom HTTP verbs because it's generally not really necessary, but I'm sure that there's some situations where you might want to be able to do that. So there is support for that as far as I know here. But in any case, you'll basically just import these various functions from the routing module under the Axum crate, depending on which verb you are trying to call an endpoint with. So back over here, let's just create a router. So I'll call it router 01, because you could actually have multiple routers, and you could have like maybe one router for vehicle management. You could have one router for customer management. You could have, one router for other resource management. As you start to build a much larger and larger project, you want to be thinking about, how do I break this down into a more structured approach that I don't have a main.rs file that's 10,000 lines long, right? So just keep that in mind. So we're going to create the new router, then we're going to call the route function here. And for those of you in the comments, I know some of you don't like the auto completion stuff here. I apologize. It's kind of VS Code's built-in auto completion fighting with Kodi as well. So you'll actually see some auto completion probably from Kodi here that's saying, hey, is this what you're trying to write? And in this case, I'm not trying to write that, so I'm just going to hit escape and close that. Let me actually disable Kodi because I don't want that to be too disruptive, but I do actually really like Kodi a lot. So let's just go ahead and disable Kodi for now. Sorry, Kodi. You'll come back later. Okay, so for this route handler, we're going to say /vehicle. So rather than going to /, which is the root of your application, we're going to go to /vehicle. And then under /vehicle, we are going to, let's start with like a get operation. So we're just gonna get a random vehicle. So we're gonna generate a vehicle on the server side and we'll send it back to the client. So that's just a very, very simple contrived example. So I'm gonna create a handler here called vehicle_get. You could call it get_vehicle. The naming convention is entirely up to you. All you have to do is tell the Axum framework what the name of your handler function is going to be. Now, obviously, this function doesn't exist, so that's why we're getting some squiggly lines here. Plus, we're missing a couple of imports here as well. But if you have the Rust Analyzer extension installed, it will actually help you do the imports, which is a huge time saver because it's a lot more of a pain to read through all the documentation and have to like manually type out all the imports. So definitely use the Rust Analyzer extension because then I can just go to router here and I can do control space and it says, oh, are you trying to use router from Axum router or directly under Axum? And it's, yes, I do. So I hit enter and it just automatically adds that use statement for me at the top of my file. So same thing for the get function over here. Again, get is one of those verb HTTP method-based functions under Axum routing that we just looked at the documentation for. So again, I'm just going to hit enter. That's the one I'm trying to use. So you'll see it adds routing get to my use list here. And then the second to last squiggly here is complaining that my function does not exist yet. Can't find function vehicle get. And I also don't have a semicolon. So we'll close off the semicolon. The remaining error here is that I don't have a vehicle get function. We're going to ignore that for just a second. We are going to have another issue here where even if we did have vehicle get, you're going to see that you have router with a generic type of unknown. That error will actually go away as soon as you call Axum serve. So you can ignore that for now. So like, let's actually do async function vehicle get and just do no parameters, no return type. So now you'll see this error that says, hey, type annotations are needed for router generic type underscore. And so that is the message that you are going to resolve by ultimately calling Axum serve. So step one is to create the Axum router. Step number two is to define the IP and port listener, TCP typically. Not even sure if you can do UDP-based REST APIs. I'm sure there's a way to somehow. In fact, I think HTTP version 3 is all UDP-based or something like that. I'm not, my memory is not serving me very well there. And then third is finally we're going to call Axum serve to launch the web server. Okay, so step two is to define the IP and port listener. So we're going to go to Tokyo Net, and then we're going to go to the TCP listener type here. And we are going to call the bind function here, and this is where we can specify the address. So you can optionally specify the address as a separate variable, just to keep the next line a little bit shorter. So say let address equal 0000 : port I don't know, pick anything from 0 to 65,535. So we'll say 6570 and put a semicolon at the end there. And then we can just pass in address. So we'll bind to that. And then we need to await and unwrap the result. And of course, we need to assign the result to a variable. So we'll say let listener equal that. And so now we have a TCP listener data structure. So now that we've got our router data structure in Axum and we have our TCP listener data structure from Tokio, now the last step is just to launch the web server. So we say Axum serve. So we want this top level function here, and you'll see it takes 2 input arguments here, very simple. And we simply pass in the listener and our router. And I was actually watching a YouTube video from another guy named Jeremy Chone. And he's got a video that's a couple of years old, but I think a lot of the things are similar. You can actually merge routers together. So if you do have multiple router objects that are all distinct from each other, that point to different resource management APIs and separate Rust modules or something like that, just for code structuring, good code practice, you can actually like merge routers together using a merge function somewhere. So you can actually just define them all separately and then merge them, and then you can pass them into your serve handler or serve function. So we're going to call serve, and then we're going to pass in listener, and then the second variable is going to be router 0, 1, and we're only going to deal with one router for now. So then we are going to await and unwrap the result there. Okay, so that is a web application. Technically, this web application should work. So what I am going to do here, by the way, we are going to be using PowerShell a little bit. So if you don't have PowerShell installed, it does run natively on macOS. You can do a brew install PowerShell. You can also install PowerShell natively on Linux. It is native. It's not Microsoft only, and it hasn't been since 2016, August of 2016, if I recall correctly. We're going to be using this command called invoke REST method, which, as the name implies, allows you to call REST methods. You can pass in headers and bodies and things like that. So very useful here. We're not going to talk about PowerShell this second, though, so we're going to do cargo run. This will compile all of our Rust dependencies, and then it will launch our Axum application. And then we can use PowerShell to actually test it out. So on the little button behind my head here, the plus sign, I'm going to launch a second terminal, and it's going to prompt me here on Windows. It's going to say, hey, there's a new application that's trying to listen on a network interface. Do you want to allow this? I say, yes, I do. And check it out. Our application is technically running. So one of the things that you'll probably want to do when you're building out REST APIs or web applications is actually think about the pattern that your clients are going to use. Like as a client, how do I want to call a REST API? And so this is often thought of as test-driven development, where you basically write the client API calls first, and you kind of define your API structure from a customer caller perspective. And then once you've defined those, you go into your server-side Rust code and you actually implement the necessary functionality to achieve what the caller is expecting. Mentally, if I start by just building out REST API endpoints without really thinking about how the client's actually going to be calling it, it ends up turning into a bunch of spaghetti code, and it really doesn't look all that pretty. So you probably want to start out by actually defining what your client invocations are going to look like. So I'm just going to define a PowerShell script file here called API tests.ps1, and also you can install the PowerShell extension for VS Code as well. So that'll help you get auto completion and whatnot. But we're going to call invoke REST method dash URI, and we're going to do HTTP localhost. So our Rust application is listening on all network interfaces, which includes localhost, but external systems could also hit the IP address of my Windows 11 system and be able to access the application as well. But for now, since I'm accessing it on the same system, I'm just going to use localhost, obviously. And then our port, I think, is 6570 here. So we're going to say 6570 slash, and then remember the route that we have here is slash vehicle. But what would happen if we just tried to access it on slash? Do you think anything would happen? Well, let's try. So if I copy this command, or if I hit F8 with the VS Code extension, it tries to execute that. And as you can see, it gets a HTTP 404 not found response. And that's because there is no route handler that serves slash. There's a route handler for slash vehicle, but not slash nothing. So this is one test. We expect this to fail, right? So root URL path should fail. We could put a little emoji there that says, no, we expect that. And then let's define another test that says, okay, well, do I get any response from slash vehicle? So we'll say get vehicle, basic example, and we'll say invoke REST method dash URI, and then HTTP localhost 6570. slash vehicle this time. Then I'll just select that and hit F8. F8 will only run the currently selected code in VS Code PowerShell. So as you can see, that time we did not get an error. Now we got an empty response. We didn't actually get any data in response from the Rust application, but it did technically invoke that web API endpoint. So we know that the Axum web application is working. If we change /vehicle to /vehicle2 or /vehicle22, anything other than vehicle, then that is going to fail because the only supported route that we've configured on our route handler is /vehicle. And specifically with a get operation. That's the other important thing. So when we're running invoke Rust method here, it's actually implied that the HTTP method is get. So if we do method get on /vehicle, that will work and get an empty response. If I change this and say, let's write another test that's called post new vehicle. So we're going to have a separate route handler that creates a new vehicle resource in our application, probably a database, ideally in the real world. But for now, we're just going to say post a new vehicle and then change the method to post. So now we're being explicit to the invoke REST method command. We're saying, I want you to call /vehicle on this IP and port using the HTTP protocol, obviously, but I want you to use the post method, not the get method. So what do you think is going to happen? Well, it's obviously going to fail, right? Because that method, HTTP 405, that method is not allowed on that route. So there is a /vehicle route, but the only supported handler is a get handler. There is no post handler. Now, we could change that, and we could implement a post handler. So to format your code a little bit nicer, you can just add the .route handlers in succession here on new lines so that you don't have a super, super long scrolly line that goes from left to right. That's hundreds of characters long on a single line. So we'll say .route again, and we'll say /vehicle again. And then this time, instead of doing get as the wrapper, we're going to do post. And you can see again, the Rust Analyzer extension says, hey, there's a post function under Axum routing module. Is that the one that you want? And we say, yes, it is. And of course, it automatically imports that under the use statement there. So then all I have to do is change the handler. So what is the async Rust function that's going to serve requests going to post /vehicle? Well, let's create one. Let's call it vehicle post. Well, that doesn't exist yet, so let's define it. So async fn vehicle post, and now we've implemented the post method, or verb, depending on your preference. They're called the same things. And so now we can do a post operation on the /vehicle endpoint here. Now there is a shorthand for this as well. So if you don't like the duplication of /vehicle and then /vehicle again, you can actually just add the post at the end of the get here. So you can chain these together and then just eliminate the duplicate vehicle handler there. And so now I'm saying, okay, for this /vehicle route, I have a handler for get, and I have a handler for post, and I have a handler for put. And I can just kind of chain them like that. And that allows me to minimize duplication of my actual route text there. Okay, so for now, we're just going to have the get and post HTTP verbs supported for this application. Now, at the moment, let's actually rerun this here. Let's go to our Rust application here on the correct tab. So we'll cancel that with Control-C and then just hit up arrow and enter to rerun it. That'll recompile our application with our latest code changes. And it's saying there is an unused import post. Is that because did I save the file? What do you mean? That is being used. Is that a bug? Kind of looks like a bug to me, honestly, because if I were to remove that, I don't believe it would compile. Would it? It is. I'm not quite sure how that is. Oh, it's probably because post is technically a function on the return type of get. I see why that works. Okay. Yeah, so that's definitely not a bug. Okay. So get returns the method router, and then I guess the method router has, all the chained methods on it. So yeah, that makes sense. If I was calling post as part of a separate route handler, like when I defined route and then route again, then it would have to be a top level function. But because I am calling post on the return type from get, that does actually work. Okay, so we've recompiled our application and we should now be able to do invoke REST method. Remember, we got HTTP 405 method not allowed. But this time, if we hit F8 to run that line, you can see it succeeds. So we did a post and it worked. And if we do a get, that works as well. But they obviously don't return anything. They're not doing anything functionally at this point in time. But that is where we are going to head next. So we are going to actually, in the get here, we are going to return a new vehicle as a JSON object. Now, how do you accomplish this? Well, first of all, you have to define a data structure that you either want to receive as a payload in a client request to the web server, or a data structure that you want to serialize as JSON or any other data format that you want to use, and then send back to the client or caller in the response or HTTP response. So we're going to define a struct called vehicle. And for that vehicle struct, we're going to have a manufacturer property called string. We're going to have a model string. We're going to have a year as, let's say, an unsigned 32-bit integer, positive only. I don't think there's any before Christ cars out there, but correct me if I'm wrong. And then we're also going to have some sort of identifier, right? So we're going to have a unique identifier here, which will just make a string value. So that'll be a UUID that we dynamically generate. So we're not going to have the caller ever specify the UUID for a vehicle. We want to control that on our back end. However, a caller, when they post or create a new vehicle resource in the database, they may need to specify things like, okay, who's the manufacturer, who's the mod, or what's the model, and then what is the year of manufacturing, what's the VIN number. Those are all inputs that you would expect the client to send to the server. But as far as the internal identifier that we're using, perhaps in a MySQL or a Postgres database or something of that nature, that ID we want to control on the REST application side, because that would not be considered a user-defined or customer-defined field. Okay, so we've defined this data structure, and you might say, all right, well, I'm going to go down to vehicle get here, and I'm going to return a vehicle. Okay, and then we're going to construct a new vehicle just statically here. So we'll say manufacturer is, let's say, Dodge. The model, we also have to call .toString on that. The model will be, let's say, Ram 1500. I'm not sure of all the different models available there. And then let's say the year is 2021. And then the ID, we're going to use UUID. So that's the package or crate name, and then the type name is UUID with a capital U at the beginning, and then there is a function called new v4, assuming that you enabled the v4 crate feature when you did cargo add, and then we'll take that UUID and do .toString on it, and so this is our constructed vehicle. So we are statically specifying all of these values. We're not allowing the caller to pass in anything at this point, whether it's query string parameters, URL path segments, body parsing, headers. We're not doing any of that right now. We are literally just saying to the caller, you're getting this vehicle every single time that you call this endpoint. So not very dynamic, but we're going to progressively get there as time goes on. So let's practice calling this now from PowerShell. So you could use PowerShell as a client. You could use Rust applications as a client. Basically, any language out there is going to support HTTP, of course, but I'm just using PowerShell for simplicity. Now, you're probably going to try to run this and say, oh, crap. Well, I cannot directly return a vehicle from one of my route handlers. And the reason for that is because there is a trait in Axum called into response. So when you send a response back to a caller from an Axum route handler, the response needs to implement the into response trait, Rust trait. And our custom data structure here, the vehicle type that we've defined in our application, does not implement into response. And so what we actually need to do is wrap it in the JSON type, which is part of Axum. So Axum JSON, this is a generic type that allows you to wrap any data structure and just basically serialize the data structure as JSON. However, your data structure has to implement the SERDI serialize trait, which is why earlier when we were doing the project setup, we added the SERDI dependency to our cargo.toml file using the cargo add command. So I'm going to hit enter to add our use statement up here so we can just call JSON without doing Axum : JSON, which would be the proper name for it. And so now you're going to see an error here saying, hey, the function definition, function signature says that you are going to return to me a JSON wrapping a vehicle, but I'm returning a vehicle. And this is essentially the same thing as doing an explicit return with a semicolon at the end. If you leave the semicolon off in Rust and you don't specify the return keyword, the last statement that does not have that semicolon in the function body is going to be the return value for that function. So just in case you're new to Rust, that's kind of how that works. So what it's saying is that the vehicle that's being returned from the function right now does not correspond to what we told the route handler is going to be returned. So what we need to do is do JSON, and then there is, I think it's from. I hope I don't get that wrong. I think it's just from. And then what we're going to do is take off the closing parenthesis there. So I just have the open parenthesis, and then we're going to wrap this entire vehicle structure that we just constructed, and we're going to close off the parentheses. So we're taking JSON from, and we're wrapping the data structure that we want to serialize and send back to the client as a JSON payload. So do you think this is going to compile? I think it might actually, because I don't see any compiler errors. Okay, part of me thought that it was not going to, and I was right, kind of right. So we are getting an error message here saying that the return type here is, this is actually very confusing, but what we're going to do is actually follow its advice here, and we're going to add the debug handler macro here to see if it helps us. And this is only available if you install the macros feature. So if we go down to feature flags here, there is macros. By default, it's not enabled. That's why we had to explicitly specify -- features equals macros among several others. But once you do that, if you go to create items here and then go down to, where is macros? Oh, attribute macros down here. There is debug handler, and you can see it's only available if you enable the macros feature. That's what that little label means right after it, is that this macro is only available if you enable that feature on the crate when you add it to your project. And of course, you can always go back to your cargo.toml file right here, and as long as you have Axum and then features, and in that array, you should see macros in there. If that's listed in there, then you should have that feature enabled. And so what we're going to do is go to our handler function.
Ẹni? Okay. Okay, ẹ ṣeun.
Functions, our route handlers, and we're going to add the debug handler to the handler functions. So let's go over here, and on the function that's having an error here, we're going to add a debug handler, and of course we have to import it. So let's just do control space and hit enter to import that macro into scope, and you should see that added up here in our use statement. That's getting longer and longer. And so let's see if the error message has changed at all. Now, the errors here are going to be a little bit confusing, but the one we're actually looking for is this one right here. The trait bound vehicle serialize is not satisfied. That is the ultimate error that we're after. I'm not totally clear on why these other errors are showing up. They are not very helpful, unfortunately, but the error that we are after is the one saying that serialize trait from SERDI. So SERDI, as the crate, defines traits called serialize and deserialize. What it's saying is that our custom vehicle data structure doesn't implement serialize, so therefore,
Yeah. Okay, okay. Ẹ ṣeun, ó ti wá. Ṣé bó ṣe kéré lọ́dọ̀ yín ni? Ó lè jẹ́ yàrá náà ló ní. Gbogbo nǹkan charge báyìí.
Axum doesn't know.
Your own fuba.
Know how to turn our vehicle data structure into a JSON representation, text representation, right? So all we have to do to fix that is go to our struct vehicle and say derive. Can't think of the right syntax for this. Derive. So debug is helpful in case we want to do print line and just pass in, all that stuff. So we'll just do derive debug. That's a pretty common thing. And then we're also going to derive SERDI serialize. So we'll do that. And that should resolve any errors. So now you can see if we go to problems here in VS Code, there are no more problems. So let's clean up our terminal here, Control L to clear the back buffer, and then we'll do cargo run. That'll recompile our application. And now that we've fixed all the compilation errors, we are good to go. And I am actually going to add in just a simple print statement here so that anytime that a client calls this route handler, we just want to log some information in the terminal just so that we can see that the server is actually working. So we're going to put in a print line macro call here. This is just part of the Rust standard library. And we're going to say caller retrieved a vehicle from Axum. Something simple like that, just so we know it did something. So let's do Control C, up arrow, enter to execute the application again. And so now let's come over to API tests.ps1 and let's call this handler right here. So /vehicle get. We'll hit F8 to run that. And I think maybe I had to select this tab here. Let's do F8 again. Sometimes it's a little weird. So yeah, so now you can see that the client, in this case PowerShell, invoke REST method, received a JSON object. Now PowerShell invoke REST method will actually take a JSON response as long as the content type header is set to application/JSON. Invoke REST method will actually take that JSON representation of any arbitrary object and it will turn it into a PowerShell object. So the reason that you're seeing this formatted output here is because PowerShell is actually getting the JSON result and it's deserializing the JSON object into a kind of anonymous PowerShell object. So what we could actually do is grab the result as a variable. So we'll capture the result rather than just spitting it out to the terminal. And then if we do $result, we can say .manufacturer. Oh, it's Dodge. We could say .model. Oh, the model is Ram 1500. So we're able to grab each individual property Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for another video on the Rust programming language. I'm going to be adding this video to my Rust playlist, so if you are not familiar with that playlist, feel free to check it out. You can access it on my channel homepage, or you can go to my channel homepage and then go to the playlists tab and you can find the Rust programming tutorial playlist there, and I should have a link to it in the description and probably in the pinned comment as well, so feel free to check out the full playlist. Now, previously in the Rust playlist, we have covered a lot of different topics, a lot of fundamentals. In fact, if we go over to the channel, right, we're going to fire up our shell. We're going to go ahead and go into I've got detail it's kind of generator. Now you don't have to take this approach. There is actually a way to build a Tokio runtime in a non-async or just standard main function. However, it's generally advisable to use this approach because it's very simple. There's no additional configuration, but there is another way that you can set up a Tokio runtime inside the main function directly. I think it's called like the spawn function or something. But what I want to focus on here is basically how we define the Axum application. So there's this struct called a router here, and the router allows us to define routes. So it has this function on it called route or method, and the route is going to take in a couple of parameters here, the path that will invoke that route, and then we also pass in the handler. And the handler in this particular case is a closure, but typically it's just an async function that you define somewhere in your Rust project. It could be in main.rs directly, or you could define a separate module file and put the handlers in there. And so you could categorize, maybe you've got, vehicles and customers and parts and all sorts of different types of resources. You can separate those out into separate Rust module files and simply reference those inside of your main.rs file. But we're not going to get super fancy here. So this is basically saying if I do a get on /, which is just the root of my application, then it's going to execute this async closure here and return the result, which is just a string value, just a static string. So then once you've defined your routes, and you can actually call route multiple times on this router, so you can define lots of different routes. Next, you have the listener, and all the listener is, it's part of the Tokio crate, and what this does is it specifies which IP addresses to listen on, and if you want it to listen on all network interfaces, whether it's localhost or the actual private IP or IPv6 addresses that you have on your system, you just set it to 0000, or if it's IPv6, I think you do like square bracket, double colon, closing square bracket instead, and I think that is how you define all IPv6 addresses. And then you specify a colon and the port number that you want to listen on. Doesn't matter what port number you choose, just any port number. Obviously, you'll have to potentially open it up in a firewall, depending on how you're trying to access it, but that's far beyond the scope of this particular video. And then you just await and unwrap the result from the listener. And then finally, once you've defined the listener, then you call Axum serve. So serve is a function directly on the Axum crate here, and you simply pass in the listener configuration that you just created with the IP and port, and then the router, which in this case is a variable called app. I don't know. You could call it router if you want to. You could call it app. It doesn't matter what you call that variable, but you just pass your router configuration into the serve function here. And then, of course, you have to await that as well. Otherwise, your application will just quit and the web server will kind of never run, right? Because you're never awaiting that feature. Okay, so let's go ahead and set that up in our application here. And we are going to be pulling in some dependencies as well. So the first thing we're going to do is add the Tokio package. So we're going to say cargo add Tokio features equals full. Then we're going to add Axum as well. So we'll say cargo add Axum. And there are a few optional features. So if you do cargo add Axum and you look at the feature list here, these are the default features that were enabled. But you'll also notice that there's some optional features down here. I'm not quite sure what these double underscore ones are here, but there is a feature here for HTTP version 2. There's one for additional macros. There's actually a macro called debug handler in Axum that's used to help you get better error messages from your route handlers from the compiler. And then there's also support for HTTP multi-part uploads, and then of course for WebSockets. WS, I believe, is just short for WebSockets there. And so that is not enabled by default. So if you wanted to add any of those features, you would just say cargo add Axum -- features equals, let's say HTTP2, and then we could say comma macros, comma WS. And so then if we scroll up again, you'll see that WS now has a plus, and so does macros, and so does HTTP2. So we are all good there. So now that we've got the Axum crate installed, there is going to be another one that we need, which is called SerDes. And I actually did a video on SerDes, on serializing and deserializing JSON data. So let's do cargo add SerDes. And then just like with the Axum crate, when you add the SerDes crate to your project here, it's not going to enable certain features by default. So there is a feature here called derive that allows us to use the derive macro to add serialize and deserialize traits to our own custom structs that we're going to build. And so we don't need SerDes JSON in order to do JSON serialization, deserialization, because Axum actually handles that for us using something called extractors. And so what we're going to do is add SerDes features derive here, but we're not going to install the SerDes JSON package. So this is going to allow us to basically just mark some of our data structures as deserializable or serializable, and then we can use those inside of our Axum route handlers to either send data back to the client in a response as JSON, or to receive a JSON payload from a client and interpret that as a data structure on the Rust server side. So that's why we add the derive feature here. And then I think that's pretty much everything that we need for now. There is actually one other crate that I almost forgot. I always add UUID as well. And this is just because when you are generating any kind of unique identifier, like we were talking about, anytime that we add a new vehicle to our auto shop, we want to have some kind of unique identifier. And you could potentially use the vehicle identification number or VIN number. But oftentimes you want to use some alternative to that because you can get in weird situations where you might have duplicate entries or something like that. And so it's really just best oftentimes to use UUIDs, Universal Unique Identifiers, also known as Global Unique Identifiers, depending on who you talk to. But that package just really helps with generating random values so that you have these, unique identifiers for various objects in your applications. Okay, so we are going to open up the source main.rs file, and the first thing we're going to do is actually set up the Tokio async runtime here. So we're going to do Tokio main, And then we're going to, of course, set our async main function here. If we don't have async there and we do apply the Tokyo main attribute up here, you'll see it actually complains and says, hey, the async keyword is missing. So, make sure you add that. So it's not even going to compile unless we add async there. So then we are not really going to copy here. We're going to type this out. And what we're going to do is basically create a new router. So we're just going to call the new function on the router type, and then we're going to call the route function one or more times on that router struct so that we can define one or more routes that we want to define. And then this get function here. So this is the verb that we're going to use for the HTTP API endpoint. So there is Axum, and then there's a child module called routing, and then under the routing module there is a function called get, and there are also other functions. If we go to create items, modules, and then go to routing,